now we will see Brewster angle. Here we have a surface. This is our surface. We have something called the inclined plane. Let's say that it is here. It's perpendicular to the surface. This would be the normal to the surface. So we have a incident ray from here. We would have a reflected ray and a refracted ray. So depending on the polarization of, for example, this incident ray, and at the angle, so of the incident angle, is how it would be polarized in the reflected direction or in the refracted direction. So we could have that the incident light coming has the direction of polarization, so the direction of the electric field could be perpendicular to the normal of the surface, that is the same as parallel to the surface, or could be parallel to the normal of the surface, that is the same as perpendicular to the surface. If it is parallel to the surface or perpendicular to this, then we would have reflection and diffraction. It would be totally reflected. Well, the polarization would be for the reflected ray would be complete polarization, and for the reflected ray would be partial polarized. So the incident rays that are parallel to the surface, that is perpendicular to the normal, the polarization in the reflected one is higher than in those that are perpendicular to the surface or parallel to the normal. And there is something called the polarized angle. This is the polarized angle, and at that incident ray, we will see that the angle between the reflected ray and the refracted ray are 90-degree angles. So let's write Snell's law. This is theta 1. This would be theta 1. This is the reflected angle, so would be also theta 1. All here we have 180 degrees minus this are 90 degrees between this theta 1 and this angle, that would be theta 2. So theta 2 is 90 minus theta 1. So Snell's law is n1 times the sine of theta 1 is equal to the index of refraction in the film times sine of 90 minus theta 1. This is sine of theta 2. So we have n1 times the sine of theta 1 is equal to n2. This is sine of 90. So let me put the n2 here. So sine of 90 cosine of minus theta 1, that is just cosine of theta 1, then plus cosine of 90 sine of negative theta, cosine of 90 is 0. So we just have this, and sine of 90 is just 1, so we just have cosine theta 1 there. So we have n1 over n2 is equal to n2 over n1 is equal to sine of theta 1 divided by cosine of theta 1, and so this is the tangent of theta 1. So theta 1 is arc tangent of n2 divided by n1. And this is called the Brewster angle, and this is the polarized angle at which the reflected and refracted ray would have 90 degrees angle between them. And here, when the light is coming at this polarized angle of incident, all the reflected ray would be totally polarized in the direction perpendicular to the page.